Hello viewers, welcome to another lesson on probability. Today we will discuss applications of Bayes theorem. Bayes theorem, one of the most important theorems of probability, as important as Pythagoras theorem is in geometry. It is a result which was stated by Reverend Thomas Bayes, and at present its use can be seen in wide variety of topics ranging from marine biology to development of spam blockers for email systems. What statement tells us? Let us just review and then get down to interpreting and applying it in different situations. Bayes theorem talks about again a sample space being partitioned by events E1, E2 and En, and in association with these events there is an event A. E1, E2, E3 etc. are partitions of the sample space. A is any event of non-zero probability associated with S. Then the Bayes theorem says that probability of EI given that A has occurred is same as probability of EI into probability of A given that EI has happened, divided by summation of probability EI into probability of A given that EI has happened for any I ranging from 1, 2, 3 up to n. Let us start with one of the applications where you will realize that the given information at times misleads us, but knowing Bayes theorem helps to put the same information in a better perspective. Suppose we have a situation where we know that a particular test correctly identifies those with a certain serious disease 94% of the time and correctly diagnoses those without the disease 98% of the time. A friend has just informed you that he has received a positive result and asked for your advice how to interpret these probabilities. He knows nothing about probability, but he feels that because the test is quite accurate, the probability that he does have the disease is quite high, likely in the 95% range. So, you do some research and find that the illness occurs in 4% of men. What is the probability that your friend actually has the disease? Now, this is just one of the situations which is actually a problem in your NCERT textbook as well. I have just turned the statements around and I am going to now interpret each of these statements and bring in the notation which will relate you to the Bayes theorem. Let us start with first defining the events. Event E1 is a man has this disease, E2 man does not have this disease, A is that the test shows up positive, that is A dash, that is the complement of A dash will become a negative test result. Now, we had a statement which says that the test correctly identifies those with a certain serious disease 94% of the time. This translates into saying that the probability of a positive test result given that the person has the disease will be 0.94. So, probability of A given that E1 has happened is equal to 0.94. Therefore, the other statement which is test correctly diagnoses those without the disease 98% of the time translates into saying probability of not A, positive and negative result. So, negative result is when the person does not have the disease. Probability of not A given that E2 person does not have the disease is 0.98, which also implies that probability of A given that E2 has happened. So, positive test result, but the person does not have the disease is 0.02. Another part of the question, the statement tells us that 96% of men do not have the disease because 4% actually have, and therefore, probability of E2 is 0.96. You discover that 4% of men have this disease. So, probability of E1 is 0.04. What is the probability that your friend actually has the disease given a positive result? So, we need to find out the probability of E1 given that A has occurred. Putting them all together, what we have now is probability of A given that E1 has happened is 0.94, probability of not A given that E2 has happened is 0.98, probability of E2 is 0.96, probability of E1 is 0.04. Therefore, we need to find out what is the probability of E1 given that A has occurred. By Bayes theorem, I have the result which tells us that probability of E1 given that A has occurred is probability of E1 into probability of A given that E1 has occurred divided by the total probability, that is probability of E1 into probability of A given that E1 has occurred plus probability of E2 into probability of A given that E2 has occurred. So, just substitute the values of each of the probabilities and you have the result which would turn out to be approximately 0.66. So, what does this calculation means for your friend? It means that he has 66.2% probability that he actually has the disease, much lesser than what he feared. Isn't that so? So, that is where the Bayes theorem comes in use. Another application will bring in more clarity. So, here is another question from your NCERT exercise on Bayes theorem. The problem states that Mr. X is known to speak truth 4 out of 5 times. Mr. X tosses a coin and reports that a head appears. What is the probability that actually there was a head? Again, identify the events. In this case, event E1 is head appears, E2 tail appears. A is Mr. X reports that head appears. What we have to now do is understand when does a person speak truth and when does he lie. In this case, probability of E1, which is same as getting a head, is 1 by 2. Probability of E2 is also 1 by 2. What is the probability of A given that E1 has happened? It's same as saying probability that Mr. X reports that head appeared when head has actually appeared, which is same as saying Mr. X speaks truth, and therefore, that should be 4 by 5. Probability of A given that E2 has happened, that is same as saying that the person has reported that head appeared, but head had not actually appeared and therefore, he lied, and that is 1 by 5. So, we have all the information that we want, that is the probability of E1, E2 and the probability of A given that E1 has happened, probability of A given that E2 has happened. What is the probability that actually there was a head is same as finding out the probability of E1 given that A has occurred. That is, it was reported as a head when head had actually occurred. So, therefore, in this case probability of E1 given A is same as probability of a head when it was reported as a head is same as by Bayes theorem, again an expression which now should be familiar. Probability of E1 into probability of A given that E1 has happened divided by probability of E1 into probability of A given that E1 has happened plus probability of E2 into probability of A given that E2 has happened. Plug in the values that we have already calculated and a simple calculation gives you the probability that actually there was a head to be 4 by 5. This question is all about interpreting the words. Understand what are the events which are partitioning the sample space. That means, when you roll a die, either a head happens or not. Along with that, what is the event associated? So, stick to the vocabulary of E1, E2 and A and things will fall in place. One more question to put it down absolutely crystal clear for all of you. The problem states that a card from a pack of 52 cards is lost. From the remaining cards of the pack, 2 cards are drawn and are found to be both diamonds. Find the probability of the lost card being a diamond. So, what are the events associated in this case? E1, lost card is a diamond card. Along with that, what can happen? That the lost card is not an diamond card. So, I have even E1, which is lost card is a diamond card, E2, lost card is not a diamond card. A, the event associated with all of them is 2 cards are drawn, and we need to find the probability that the lost card was a diamond, given that these 2 cards that are drawn are found to be both diamonds. So, we have gone 2 cards out of remaining cards, we know that they are diamond cards. What is the probability of E1? Same as that of a diamond card, 13 favorable divided by 52. Not a diamond card, there are 39 cards other than the diamond cards in a pack of cards. So, it is 3 by 4. Probability of A given that E1 has happened. So, 2 diamond cards knowing that a diamond card was lost is same as, because 1 diamond card lost. So, there are 12 favorable, total is 51. The second card, since first was a diamond, will again have 1 less. So, 11 over 50, whereas probability of A given that E2 will become 13 by 51, because the favorable have remained 13, diamond is not lost, but 1 card is lost. So, total number reduces to 51. Second card, because 1 diamond is now taken out, will reduce to 12, total 50. We want to find the probability of E1 given that A has happened. That is where Bayes theorem comes in. Same result, you just need to plug in the values that we had calculated. In this case, its probability of E1 is 1 by 4, probability of E2 is 3 by 4. Probability of A given that E1 or E2 has happened is the product of the card, first card being diamond and second card being diamond, knowing whether a diamond is lost or not. Simple calculation, because 4, 51, 50 is common in both numerator denominator, 12 is common. So, do not need to multiply, it should simplify very easily to 11 by 50, and that is the probability of lost card being a diamond. So, the 3 problems that we discussed today are one of the very important set of problems from Bayes, very often tested also by CBSE. So, if you are one of those students who has been struggling with Bayes, I hope our lesson has made a difference. All the best and see you again.